Hello, my name is Stefon, and this is my big data briefing for Oregon Health and Science University. To start, we need to understand what big data is. According to Oracle, it's defined as complex data sets that are larger than standard processing software can manage. These data sets vary between structured and unstructured raw data in different formats, and it should be a paradigm shift in our thoughts of data sets, where and what we collect, and the insights that we gain from the analysis of that data, according to Kimball. Fortunately, OHSU collects data every day. This can come from email mining, text mining, student information, patient information, and employee or electronic health records. These records and all of this data comprise everything that makes big data for OHSU. As such, there are some challenges that come with that. The first challenge is the size of the data. As so much data is collected, it produces larger and larger file sizes. Storing that data, how you access that data, and who governs that data then becomes extremely important. As OHSU collects data from so many different departments, that size grows on a daily basis. As such, we're presented with the next challenge of separate siloed data sets. From having a different data warehouse for students, for patients, and for staff, it ends up creating separate areas with separate presentation areas for departments. That presents a challenge as sometimes other departments might need other data that's not present in their own data set. That leads us into the next challenge of the value of the data that is collected. How is it cleaned, presented, and how is it going through an ETL process? That's extraction, transforming, and loading. What value do we gain from the data that is in our data set? From the perspective of a software developer, everything is constantly changing and evolving. The tools that we use, the programs that we use. One such program is Apache Hadoop, which has been updated for years now, and the most recent one being this year in January. As such, that poses a challenge as new tools will have to be learned, different changes will have to be updated, and everyone will need to be briefed on everything that they need to learn in order to be successful at understanding that big data. As stated, data warehouses are typically where the data is stored. When thinking of data warehouses, we also need to understand the different architecture that goes behind that. According to Smith, data warehouse architectures used to facilitate one version of truth for the organization that bases its forecasts and big decisions on. The most common type of architecture is a three-tier architecture that comprises a bottom, middle, and top tier. This is extremely similar to what I would recommend, the Kimball Data Warehouse BI architecture. As we see here, these are the two different architectures as presented by Smith and Kimball. On the left, we see that Smith has a very, very similar layout. There's the operational systems that lead to the transaction databases. It goes through an ETL process. And then, from that process, it goes into the warehouse. After that, there's the presentation area, which for the Kimball process, which is why I recommend it, there is always dimensional thinking involved. So then, what are the best practices for big data for OHSU? Well, first, the data that you collect must align with your business goals. It has to meet the needs of what the business is doing, what its mission is. You must think dimensionally and separate everything into facts and dimensions. Here, soon you'll see what a dimensional model looks like, how we can use a star schema and an OLAP cube to understand our data. The last practice is, of course, to invest in data governance. After you think dimensionally and separate everything into fact tables, it's always best to invest in data governance. understanding who knows what goes where, who cleans the data, and what process it goes through. So to enforce this, as stated earlier, OHSU has many different segments and departments. The data that those departments collect must be consistent, clean, usable, and reliable. Bresnik states that governance should be geared towards enabling users to trust their data. So, for each department, my recommendation would be to create departmental teams that can govern the data, put it through the ETL process, and then build trust with the users in the departments by creating clean, usable, and trustworthy data sets. Before you can do any governance and integrity enforcement, as stated earlier, it's always best to think dimensionally. Here I have an example of a Kimball dimensional model. As we see, it's a star schema. So there are 4 different things here: the healthcare department, patients, date, and EHR that comprise a transaction whenever someone comes into an ER, for example. Here on the right is the OLAP cube. It shows segments of data by date, patient and EHR, and healthcare department. This is just one example of a dimensional model that should be implemented in OHSU for the big data and data warehouse. Thank you so much for your time. I hope that you enjoyed this video and understanding how big data can affect Oregon Health and Science University. I am here for any questions. Should you ask, just leave them in the comments.